The United Kingdom has recently received a substantial boost in its natural resources reserves through an ambitious project. This initiative is poised to tackle some critical issues facing the country, such as the dwindling availability of valuable natural resources like gas and oil, as well as the challenges posed by weakening exports. To unlock these valuable resources, a massive underground mine is being constructed. This mine is set to be Europe's deepest, making it virtually invisible to the naked eye. This is Woodsmith Polyhalite Mine, a groundbreaking venture by Anglo American, stands as Britain's inaugural large-scale mine in decades. When this advanced superminer reaches completion, it will claim the title of the world's largest and highest-grade polyhalite mine. This distinction arises from the discovery of a polyhalite seam in the UK possessing unparalleled purity and situated in a location conducive to processing and shipping. This remarkable find represents a rare commodity exclusive to Britain, and the mine's success could inject a staggering $100 billion into the UK economy over the ensuing 50 years. Before delving into the intricacies of the mine, it's crucial to provide a brief overview of polyhalite, the newcomer in the fertilizer arena. Polyhalite, often hailed as the Rolls-Royce of potash, falls within the category of potash, a potassium-rich, salt-based mineral widely used as fertilizer globally. What sets polyhalite apart is its composition, encompassing 4 out of the 6 essential nutrients crucial for the growth of all plant life: potassium, magnesium, calcium, and sulfur. Under the brand name Poly4, Anglo American aspires to position it as a multi-nutrient, low-chloride, ultra-low-carbon fertilizer certified for organic use. This product not only promises increased crop yields, but also seeks to enhance and safeguard soil conditions. Situated beneath the North York Moors National Park in Yorkshire, England, approximately 2 miles south of Whitby, the mine houses a potential resource of 2.69 billion tons of polyhalite. This abundance ensures a lifespan for the mine of approximately 100 years, with an identified reserve of 290 million tons, extending its operational life beyond 30 years. The origins of this extraordinary deposit trace back around 260 million years to an ancient sea's desiccation. The discovery of polyhalite itself was serendipitous, dating back to the 1930s when oil prospectors drilling for oil stumbled upon this valuable mineral. Decades later, it was recognized as a precious resource, thanks to 2 geologists after whom the mine is aptly named. The uniqueness of the Woodsmith mine extends beyond its colossal deposit to its location. This polyhalite seam, not only existing in such abundance, but also at an extraordinary depth, happens to be in North Yorkshire near Whitby. The mine's production is slated to commence in 2027, generating over 2,000 jobs for the local area during its construction phase. Accessible via 2 main shafts, each reaching a depth of 1.5 kilometers, almost 1 mile, the mine will boast the title of the deepest mine in Europe. Given its location within the cherished national park, stringent criteria were established to ensure minimal impact during the mine's construction. Remarkably, unless observed from a helicopter, the mine remains virtually invisible, resembling ordinary farm buildings. The innovative design includes concealing the giant winding towers, also known as head frames, in 60-meter deep chambers to minimize visual impact. These chambers, a world first in mining, are constructed using diaphragm walling. The main mine shafts are mechanically sunk using a 3rd-generation machine named a shaft boring roadheader, drawing inspiration from tunnel boring machines. This machine, employed since its descent into the 4 shafts, operates in a star pattern, cutting 200 millimeters deep with each pass. Every 5 cycles, the shaft gains 1 meter in depth. To enhance safety during excavation, the shaft boring roadheader is equipped with 2 robotic probes to test the ground ahead. The mining process involves a combination of drill and blast techniques alongside continuous mining machines. The extracted ore is then transported through flexible conveyor belts back to the production shaft. Hoisted up to 360 meters below the surface, the ore is transferred to the mineral transport system, a remarkable engineering feat. The mineral transport system comprises a 23-mile underground conveyor belt, the longest in the world, connecting the Woodsmith mine to the materials handling facility at Wilton. This extensive tunnel, currently under construction, is designed to minimize costs, complications, and pollution associated with traditional transportation methods such as trucks and trains. The tunnel is being excavated using a tunnel boring machine, TBM, which began its journey at the Wilton site before heading towards Woodsmith. The Wilton site also hosts the concrete factory, supplying segments for lining the tunnel. The TBM, with its giant multi-rotor cutting head, nibbles away at the rock, and every few meters, giant concrete segments are installed to line the tunnel. Once a concrete ring is completed, a machine secures it in place between the concrete lining and the rock. The TBM, employing high hydraulic jacks, propels itself forward, continuing the 23-mile journey. The mineral transport system includes a 23-mile-long conveyor belt capable of transporting ore at a speed of 6.5 meters per second. This system, along with a maintenance railway and utility and power cables, ensures the ore never surfaces until it reaches the mineral handling facility, a 4-kilometer trip from the port. Upon reaching the mineral handling facility, the ore undergoes several processing stages, transforming it into the final product. The ore is initially deposited in a storage shed, and an automated conveyor belt system guides it through a continuous production line. The process involves crushing the ore to a fine powder, grading to remove large pieces, granulating to a uniform size using a natural starch, and finally, screening and drying the granules. Remarkably, thanks to its 88.8% purity, the processing of polyhalite at the facility involves minimal waste, with no need for chemical usage. The final leg of the journey encompasses a 4-kilometer-long, fully concealed conveyor belt, loading the polyhalite onto cargo ships at the Brand Sands port facility on the River Tees. This port serves as the UK's northern gateway to global shipping routes. Anglo American aims to ship up to 13 million tons of Poly4 annually worldwide, with the first shipment expected in 2027. The global demand for polyhalite arises from projections indicating a population of 10 billion by 2050. With limited arable land, farmers seek ways to increase yields sustainably. Agricultural universities and research institutions have conducted over 1,000 crop trials across 44 countries, consistently showcasing polyhalite's superiority over other potassium fertilizers in both crop yields and quality. In conclusion, the Woodsmith polyhalite mine represents a remarkable endeavor, combining cutting-edge technology, innovative engineering, and environmental consciousness. As the first of its kind in Britain for decades, it not only stands as a testament to scientific and industrial progress, but also addresses the critical need for sustainable agricultural practices to feed a growing global population.